Hi everyone, we are Dahua, Qiuze, Yi, Yuxiang, here to present you our AlphaNLP final project. Here's an overview of our QA architecture. For the sake of time, we won't go over it, but we'll go into details over important modules later in this video. You're more than welcome to pause and have a close look. First of all, about preprocessing. We built a general preprocessing module shared by both question generation and question answering system. This module would first do coreference resolution for a given document, and then segment the document and generate named entity types and POS tag for each word. After the general preprocessing, we first filter sentences or tokens that are not suitable for question generation. Before doing that, we implemented dependency parsing to each sentence to get the syntax. Then we filtered all information contained within parentheses and also delete sentences without a dependency root. Finally, we extract clauses from the sentence, so we can get the main clause and other clauses if the sentence contains more than one clause. For binary question, the first type is positive binary question generated from the main clause. Notice from the example that we also consider the tense here to make the question grammatically correct. Apart from the main clause, we also generate binary questions from relative clauses. To increase questions difficulty, we use two techniques. The first is word replacement. We randomly replace adjectives and nouns with their synonyms and antonyms using WordNet. This makes searching related tags harder because simply matching the exact word becomes unreliable. In addition, replacing words with their antonyms makes binary questions more unpredictable because answers can change to no or remain yes. The second is named entity replacement. This also makes searching more difficult. The answer of this type of questions is always no. For WH questions, the first one is what who questions generated from main clauses. We simply replace the NP subject with what or who according to its NER tag. The next type is what is plus N subject based on the pattern NP is NP. Then, we generated when, where, how long questions by finding special prepositional phrases and who word questions directly from relative clauses starting with who and which. The final step for question generation is post-processing. We filtered questions with the subject with POS tag and questions containing too many characters. Then, we fixed capitalization for special words like persons' names and checked the correctness of punctuation. Finally, we rank these questions heuristically based on features like length, question types, whether the question contains pronouns, and etc. If n is larger than the number of questions we generated, we just repeat the last question. Moving to question answering, the first step is sentence retrieval. Considering word replacements that are used in question generation, we believe simple methods which only rely on bag of words will not perform well. We use word embedding and named entity matching to improve the performance. When a word is replaced, the new word shares the same context word. Therefore, it is reasonable to assume that the new word has a similar word embedding of the original word. We define sentence embedding as the average word embeddings in a sentence. We give a score to each sentence as cosine similarity between the sentence embedding of the question and the sentence. To reduce noises, we also remove all stop words and then lemmatized each word before calculating sentence embeddings. For example, I love eating oranges and I hate having apple has high similarity score, and I love eating oranges and I play video games has low similarity score despite the fact that they both share only one word in common. Word embedding doesn't work well on named entities, but named entities are often the most important information. To address this issue, we give scores for matching named entities as well. We give high score for exact match, medium score for partially match, like America and American, and a low score for type match, such as America and China, and zero score otherwise. Finally, we take a weighted average between score from named entity and score from sentence embedding, and return the best scored sentence of the target sentence to generate answers in the next step. After we retrieve the target sentence, for binary answering, we extract the default answer from the target sentence based on whether there's a negation, like no, not, none in it. After that, we extract noun chunks, adjective and adverb chunks, the verb chunks from the target sentence and the given question respectively. Take the different sets by subtracting the question chunks with target sentence chunks. That is to say, to find out all chunks appeared in the question but not in target sentence. For each of these chunks, we then examine if its synonym or antonym appeared in the target sentence. If there is some antonym, we total the default answer. Otherwise, we remain the default answer. Here's an example of binary question answering for your reference. We don't have time to go over it in this video. For WH question answering, in general, we'll return the best score sentence. We also use named entity to concisely answer the questions. For example, if the question asks for a person's name, then if there is a unique name in the sentence, we'll return that. However, SPACY named entity library often gives wrong named entity types. So if there are multiple named entities of the same type, we'll only return the whole sentence. Finally, we have evaluated our question answering algorithms over the 2010 Spring datasets and achieved around 70% accuracy for binary answering and around 90% accuracy for WH answering. Thank you, that's all.